Find the maximum value of the function f of x. In this problem, we've been provided a function f of x, which we want to maximize. When plotted, we notice f of x is a plane, as shown in brown, which increases as the variables x1 and x2 increase. We've also been provided a constraint, where x1 squared plus x2 squared must equal 5. When plotted in 3 dimensions, this constraint appears like a hollow cylinder. It may be easier to see the optimal solution if we create a contour plot of the objective function, where each diagonal line represents a level set, which is a constant value of the function f of x. Based on our objective function, 2 times x1 plus 3 times x2 plus 4, we notice that the level sets increase as we move towards greater values of x1 and x2. And lower values of f of x occur if we move in the opposite direction. Next, we'll plot our constraint, which appears as a circle in the contour plot, centered on the origin and having a radius of the square root of 5. Since our solution must lie somewhere on this circle, we'll choose the point on the circle with the largest value of f of x, which is at point x star. In other words, this point x star is located at the intersection of the circle and the level set having the highest value for f of x. We notice the gradient of the objective function points 2 units in the x1 direction for every 3 units in the x2 direction. So, if we plug in 2/3 times x2 for x1 in the equality constraint, we find that x2 equals plus or minus 1.86. From the contour plot, we know x2 is positive for the optimal value x star. Therefore, we'll plug in positive 1.86 for x2, which makes our value of x1 equal to 1.24 at the optimal point x star. Since the problem asks to find the maximum value of f of x, we'll plug in values of 1.24 for x1 and 1.86 for x2, and the maximum value of f of x equals 12.06. When reviewing the possible solutions, the answer is D.